Hello students. Hello and welcome to this video on determinants. In this video, we will solve question number 101 to 110. We have completed 100 problems in previous video. The link to download the PDF of algebra and trigonometry will be in description. At the end, I will show you how you can download and maintain updated copy of the math PDFs, as well as I will show you my question answer website where you can come and ask questions and get answers. The reason is you cannot write mathematics like this in YouTube comments. So it is best if you can come and ask questions and answers over the website, because simply you can't write this sigma like notation r is equal to 1 to n in YouTube. You can't do that. Okay. So without further ado, let's get started. Question 101 says that if dr is the determinant rx n times n plus 1 over 2, 2r minus 1 y n times 3n minus 1 over 2, 3r minus 2 z n times 3n minus 1 over 2, then show that sigma r is equal to 1 to n dr is equal to 0. So we have sigma r is equal to 1 to n dr is equal to d1 plus d2 up to dn. So this essentially translates into sigma over the columns of R. Okay. Now, all right. So there is something wrong here. This shouldn't be n times 3n minus 1 over 2. These two are equal. Okay. So there is something wrong here. Okay. I will correct this. So for now, we take this as n square. All right. For now, this cell, second row and third column is n square. So now this sigma, when we perform the sum, it becomes n times n plus 1 over 2 n square and n times 3n minus 1 over 2. So this first column and third columns become identical, so it is equal to 0. So as you can see, this cell of second row and third column should be n square. Otherwise, the two columns won't be equal. So it looks like there is a typing mistake here, because this cell, second row, third column, and third row, third column, both are identical. I will fix it. It is incorrect. It looks like a copy paste problem. Okay. So we move on to question 102. Without expanding the determinant, show that the value of the determinant minus 5, 3 plus 5i, 3 upon 2 minus 4i, 3 minus 5i, 8, 4 plus 5i, 3 over 2 plus 4i, 4 minus 5i, and 9 is real. So we don't have to expand, but we have to show that the determinants is purely real. So we are given delta is equal to this. Now we calculate the conjugate of this. Okay. So you know by the formula that we need to negate the imaginary part. So this plus I becomes minus I in the conjugate. Minus 4i becomes plus 4i. And this minus 5i will become plus 5i, and this plus 5i will become minus 4i, and this plus 4i will become minus 4i, and so on. Now, if we exchange the rows and columns, then we will see that delta is equal to delta bar. And we know that from complex numbers, that if z is a complex number and z is equal to z bar, then z is purely real. And from there, we can draw the analogy that delta is purely real. Now we move on to question 103. It says prove that the determinant minus 2a, a plus b, b plus c, b plus a minus 2b, b plus c, c plus a, c plus b minus 2c is equal to 4 times a plus b times b plus c times c plus a. So what we do here in this determinant is we put b is equal to minus c. So our determinant is this. Then we do R1 is equal to R1 minus R1 plus R3. Okay. R1 is equal to R1 plus R3. So our determinant is now this. Once we have this, we do C2 is equal to C2 plus C1 and C3 is equal to C3 plus C1. So we get double zeros. And then upon evaluation, we get C minus A times A square minus C square minus A square minus C square is equal to 0. So we see that B plus C is a factor of delta because delta becomes 0. Similarly, we can prove that A plus B and C plus A are also the factors of delta. So we see upon examination of determinant, each term of the left-hand side and right-hand side is a homogeneous expression in ABC of third degree. So the determinant is equal to K times B plus C, C plus A plus B, where K is independent of ABC. Now let's look at this statement, okay? That's how this both left-hand side and right-hand side are homogeneous expressions of ABC of third degree. So we have got this factor B plus C, A plus B, and C plus A, okay? So the multiplication of these three factors would be B plus A times A plus B times C plus A, which will be of third degree, right? Now you look at the determinant here, okay? So this is the determinant. Now if we evaluate along this cell, it will be these two multiplied, they will be 2 degrees, and then this will be third degree. So similarly, you can take this cell A plus B, so this is 1 degree, and then you multiply these two, you get second degree or rather third degree. Okay, these two when you multiply, you will get second degree, and this will make it third degree. So that's how we can say that both left hand side and right hand side are homogeneous expression in ABC of third degree. So we have got this. Okay. Once we have this, we can put A is equal to 0, B is equal to 1, C is equal to 1, and we immediately see that K is equal to 4. Now we will solve question number 104. We are given that FR of X, comma GR of X, comma HR of X, where R is 1, 2, 3, are polynomials in X such that FR of A is equal to GR of A is equal to HR of A. And capital F of X is equal to F1 of X, F2 of X, F3 of X, G1 of X, G2 of X, G3 of X, and H1 of X, H2 of X, H3 of X. Then we have to find the F prime X, F prime of X, that is first differential of F. So what we do is we write F dash A is equal to, that is capital F dash will be equal to, we differentiate rows one by one and then we put A. So this becomes, this first row is the first differential of Fi, and second and third rows are same, but we put instead of X, we are evaluating on A. The second determinant, second row would be first differential of G, and third determinant will have first differential of H. Now from here we know that Fa is equal to Gr is equal to Hr. So this second row and third row will be equal here, making it 0. First row and third row is equal here, making it 0. And first row and second row is equal, making it 0. So we have that, okay? So all determinants are equal to 0. So our F dash of X will be equal to 0. Okay, now we solve question number 105. Let alpha be a repeated root of quadratic equation f of x is equal to 0 and a of x, b of x, c of x be polynomials of degree 3, 4, 5, so that delta x is equal to a of x, b of x, c of x, a alpha, b alpha, c alpha, a prime alpha, b prime alpha, c prime alpha is divisible by fx, where prime denotes a derivative. So we are given that f of x is equal to a quadratic equation with a repeated root alpha. Okay, it is given here. So f of x will be AR x minus alpha whole square, where AR is a constant. Now delta x will be a polynomial of degree having a maximum value of 5. How this is 5? Because assume we expand along this, so it will have degree 2. Now this will have a degree 2, so 2 plus 2, 4, and this will have a degree 5, so it will have a maximum degree of 5. Now delta alpha is obviously 0 because first and second rows are identical. Now we do delta prime alpha. So it will be A prime alpha, B prime alpha, C prime alpha. That is the first row, first determinant. The second determinant would be, so in the first determinant, first row and the third row are equal. Now, if we differentiate the second row, the first row would be A alpha, B alpha, C alpha. If we differentiate the second row, then the second row and third row will be identical. If we differentiate the third row, then first two rows will be identical. So all rows will be equal to 0. And thus we can say that delta of x is equal to 0 has two roots equal to alpha. So delta x is equal to x minus alpha whole square g of x, where g of x is a polynomial of third degree at most. So now delta x is equal to alpha x minus alpha whole square g of x upon a. So we multiply and divide by a. Now a x minus alpha whole square h of x, where h of x is equal to g of x upon a. This should be a. So we can say that delta x is equal to fx into hx, where hx is a polynomial in x. Hence delta x is divisible by f of x. Question 106 says that prove that cos theta plus alpha, cos theta plus beta, cos theta plus gamma, sin theta plus alpha, sin theta plus beta, sin theta plus gamma, sin beta minus alpha, sin gamma minus alpha, sin alpha minus beta is independent of theta. So we have this determinant, okay, delta. Now what we do is we differentiate it with respect to theta. So first row becomes minus sin theta plus alpha minus sin theta plus beta minus sin theta plus gamma. The second row here becomes cos theta plus alpha, cos theta plus beta, cos theta plus gamma. So this will become 0 immediately, right? The first and second row is 0. Okay. This is also 0 because first row and second row are identical, right? You see, this is theta plus alpha, this is theta plus alpha, only minus theta take common. So first we determine answer 0. To differentiate the third row, and third row does not contain theta, so it will be all 0. Now entire row is 0, so the determinant will be 0. So we see that d delta upon d theta is equal to 0. That means that delta is a constant which will be independent of theta. Question 107 says that if f, g, h are differential functions of x and delta is equal to f, g, h, f prime, g prime, h prime, x square f double prime, x square g double prime, x square h double prime, prove that delta prime is equal to f, g, h, f prime, g prime, h prime, x cube f prime whole prime, x cube y double prime whole prime, x cube h double prime whole prime. Okay, so this is what we have to prove that. So what we do here is we write delta is equal to f x f prime plus f. Okay, so f prime is what? So let's consider this function. So f prime is equal to df upon dx. So it will be, if we consider it of second degree, that will be xf prime plus f. And similarly, xg prime plus g and xh prime plus h. Similarly, if we do double differentiation on this, we will get x square f double prime plus 4x f prime plus 2f, and so on. So once we have this determinant, what we do is we do R2 minus R1 and R3 is equal to R3 minus 2R1. The factors of F, the components F and F will be cleaned out from the second and third row. Now we do R3 is equal to R3 minus 4R2. So here 4xf prime, this should be 4xg prime and 4xh prime. There is typing mistake. So these will be eliminated. Once we have that, we can take out x. We will be left with f dh, f prime, d prime, h prime, f double prime, d double prime, h double prime. Now we can take this x cube and put it in the third one. So this is our delta. All right. Once we have our delta, we can get delta prime is equal to first row differentiated, second row differentiated, and third row differentiated. So first here, the first row and second row is 0. Second row and third row is equal to 0 because we can take x cube out. And here we will be left with this. Okay. So that's how we have proven the equality. Now question 108 says that if f of x is equal to x to the power n sin x cos x and prime sin n pi upon 2 cos n pi upon 2 a square x a cube, then show that nth differential of fx is equal to 0 where x is equal to 0. So we have to differentiate this n times. So we differentiate everything n times in the first row because second and third row are made of constants. Now, if y is equal to x to the power n, y1 is equal to n x to the power n minus 1, y2 is equal to n into n minus 1, and similarly yn will become n factorial. Now, the sin x differential, it will become cos x, that is pi by 2 plus x. Second differential will be cos pi by 2 plus x, and then we will have sin pi by 2 plus pi by 2 plus x. So proceeding similarly, yn will be sin n pi by 2 plus x. Similarly, we will have the same story for cos x. It will become n pi by 2 plus x. So our nth order differential is n prime sin n pi upon 2 plus x cos n pi upon 2 plus x n factorial sin n pi by 2 cos n pi by 2. Okay. Now, once we have this, we put x is equal to 0, right? So we have to put this x is equal to 0, where x is equal to 0. So we see that the first and second rows become identical, and therefore the nth differential of fx upon fx will be equal to 0. Now we move on to question 109. We have to prove that cos a minus p, cos a minus q, cos a minus r, cos b minus p, cos b minus q, cos q minus r, cos c minus p, cos c minus q, cos c minus r. This should be b. This shouldn't be q. Okay. This should be equal to 0. Remember that this is equal to b. So what we do is we expand the entire determinant. Okay. All right. Now, how this came into being. Okay. So we will have to split it all together. So this is cos a, cos p, sin a, sin p. So if we split it, I'm not sure. Hang on, let me see. So this is equal to 0. Give me a few seconds to figure this out, how the solution came into being. Okay, this step I think I skipped mentioning. Okay, so this is not very clear solution. So we read this as an alternative. We can expand the determinant along the first column and then split the addition taking cos p sin p common and repeat it further to get the desired result. Okay. So what we do here is we split this. So one determinant will have cos A, cos P, cos B, cos P, cos C, cos P. Okay, so we can take out cos P here. So the determinant will be cos A, cos B, cos C, cos A, cos Q, cos B plus sin A, sin Q. So these two columns will be same for the first determinant. Now first column will be cos A, cos B, cos C. And for the second determinant, it would be sin A, sin B, sin C. Okay, so first column will be cos A, cos B, cos P, sin A, sin B, sin C. And then we split this column of that. Okay, so then we can take cos Q column and sin Q column. All right. So what we will have is cos A, cos B, cos C, cos A, cos B, cos C, and then we'll have four determinants of this, right? And then here it will be 8. So eventually you will see that column sum, all the determinants will end up being 0, because where cos A, cos B, cos C and cos A, cos B, cos C, that will be 0. And then sin A, sin B, sin D, sin A, sin B, so it will be 0. So essentially what we will have is cos A, cos B, cos C, sin A, sin B, sin C. So these two are the factors which will be different. And then the other determinants will be cos P, cos Q, cos R, sin P, sin Q, sin R. Okay. So that's how we have the result. All right. We don't need to get into this, but we will end up on this only. So this alternative you can take. I'm not very sure how this came into being. So go on splitting this. Okay. So you will see cos A, cos B, cos C, cos A, cos B, cos C will come into one determinants. What I will do is I will split this determinant and I'll show you probably in the next video. Okay, 109 number. This we have to show in the next video. I'll remember it. Question 110 says that prove that 2bc minus a square c square b square c square 2bc minus b square a square b square a square 2bc minus c square is equal to a cube plus b cube plus c cube minus 3abc whole square. So we know that ABC, BCA, CAB is equal to 3ABC, A cube minus B cube minus C cube. So if you square this, we square the determinant. Okay. So here what we do is we do C1 is equal to minus C1. So we negate the first column. And we also exchange the second and third column. So we'll have this. Now the product of these two determinants is this. So that's how we have proven this. So what I think is, let me think a bit here. This should not be plus. This should be a product sign, okay? So that's how we get this. If this is product sign, then this should be equal. So cos A, cos P, sin A, sin P, 0, 0, that is our first one. Cos A, cos Q, sin A, sin Q, 0 into 0, that is second. And cos A, cos R, sin A, sin R plus 0. So this should be a multiplication sign, just like here. Okay. So here it is A minus A is A square, B and C is BC, B and C is BC. Yeah. It is a multiplication. It is multiplication, not plus. So if you look carefully, it is product of these two, and that's how we got it 0. Okay, no need to explain it anymore. I'll change the sign here. Leaving out plus. This is multiplication. Okay. Sorry for the brain fade moment. So with this, we come to the end of 110 questions. Now I'll show you my website, which is astrologer.org. You can download algebra, trigonometry, and geometry books from here. Note that when you download the PDF, it won't have dates, so you add this date to the downloaded PDF. So that after 15 or 30 days, when you come back, you find the PDF date change, you can download again and update the PDF. Note that there are lots of typing mistakes, as you know by now. So take what is written with a grain of salt. Now, I cannot put the date in the PDF because that will break all the existing links and will make it invalid. This HTML format will go away very soon for coordinate geometry. I'm not happy with the typesetting quality of MacBook. So I'm again going back to text and we will have only PDF. So now the question answer website is the 8th link, which is kundika.afshabak.org. You can come here and make a login and ask and answer questions. For mathematics, the relevant tags are algebra, calculus, coordinate geometry, probability, trigonometry, and mathematics. And if you need more tags, I will add those. So please make a login here and ask questions or answer questions given by others. I will be able to answer questions related to these up to class 12. So let's build a community and learn from each other by asking and answering questions. So with this, I will end this video here. And so 109 won't have any solution. It is just a multiplication chain. It is not plus. So with this, I will end this video here, and we will meet again tomorrow with 10 more questions on determinants. So till then, stay curious, keep learning, and most importantly, enjoy.